Hi, I'm Nick,
I'm Ryzir.
and today we're going to teach you kids compound interest. So, you may be wondering, how would you start off in your little journey through compound interest? Well, some knowledge you may need to know before beginning is that in order to solve compound interest, you must know how to use E to solve problems. And some basic math skills you may need to know is PEMDAS and how to solve equations with exponents. Some vocab for this section that you may require is I, which is used to show the money at the end of a problem. P, which is the principal or the money at the beginning of the problem. R, which is the annual rate, annual interest rate. N, which is the number of times compounded per year. Or times in years added every second of every day. To use this on a graph calculator, you would use the table to show the amount of increase or decrease in the year, and E on the graphing calculator. If you find that on your graph, look around, find that on your graph calculator.
And we also have a graphic calculator for you to demonstrate those things.
Is used because it is a natural log base and is equal to 2.178. Some common mistakes made in doing compound interest is forgetting when and when not to use 1 in an equation, and another is not multiplying time times by number of times compounding. Some important tips on your journey through compound interest is PERT, which is the equation for compounding continuously, which we will show you later. And some real-life applications for compound interest, this being one of the things that you truly will use in your later on careers in life, is banking, loans, interest, stocks, science, and savings. Now, we're going to show you some examples on how to do compound interest.
Okay, so what I have here is a problem mapped out, and this problem uses interest rate. The problem asks you, how much money will you have when you invest $1,000 into your bank, compounded quarterly at a rate of 6% for 2 years. Now, where you want to start with this is write down your equation, which is I, the end product, equals P, the start amount, 1 plus R. And the reason you use 1 in this equation is because you want to add on the $1,000 you already have. And then,
Did you read the problem?
I did. Okay. To the power of N times T. Now, N is the number of times compounded per year, and T is the time in years. So after you do that, put in all your information that you know. So I equals 1,000. 1 plus. When you use a rate, use it in decimal form. So 0.06. And then the N, which is quarterly, means every 4 times a year, multiplied by 2 years. And another thing, always divide your rate by N. So let's see, 0.06 divided by 4. Now we're going to go to our handy dandy graphing calculator here. We're going to do on 0.06 divided by 4, which is 0.015. Okay, so when we put that in, I equals 1,000. 1 plus 0.015 to the power of 4 to the second, or to the power of 8. Now the next step that you want to take is to actually take 1 plus 0.015 to the 8th power, So we'll do that in a handy dandy graphic calculator here. And then plus 1, because we have to add our 1, to the power of 8. Which gives us a very big decimal, 1.126.
Why don't you go ahead and round that down to 3?
We will, yeah. So we're going to use I equals 1,000 over 1.26. That's what we're going to do. And then multiply that together. So this multiplied by 1,000. Your answer is I equals 1.126, and then about 50 cents. And there you go. It means after 2 years at a rate of 6% every 3 months, I believe, is quarterly. By the end of 2 years, you'll have $1,000. 126. Nice amount of money. Now on to our next problem. Oh, I gotta get up.
We're getting a little harder here, folks. Stick with us now.
Next problem is, how long will it take you to reach $60,000 if you invested in a failing stock, a total of 100 grand? The money is decreasing at a rate of 25% per year. So this problem, instead of our original problem, it's decreasing over time. So in this one, when you set up your equation, you want to do I equals P. You don't want to put a 1. Actually, you want to subtract it because it's decreasing. And a 25%, 0.25, decreasing over time. Bam. I should have put our start amount, which is 60. No, 100. I'll do that later. To a rate of per year. So our rate is 25. Rate times time. Time is per year. We have to find t. That's the problem. We have to find t. How long will it take? Now, currently what we have, since it's per year, there's no n, because every year. So I, which will be 60K, equals 100K. And then 1 minus 0.25, which we can subtract and make it 0.75. So the 100,000 multiplied.
Want some cheese fries?
Handy dandy calculator. 100,000, as you see, times 0.75 means we would lose about 75K per year. No. It's 75T. That's it. Okay, and then we have 60K. So after 1 year, you'd have 75,000. And now what we can do easily is we can just go to Y, one of the really handy usefuls, okay?
We spoke on this earlier, folks.
If you have start with 100,000, decreasing at a 0.75 rate, and we don't know what X is, and X will be our T. Second table it, you can see that after the first year, you lose 75K, bam, as we just got. And to reach 60K, between the first and second year, it drops from 75 to 56 to 50. So it will take about 2 years to drop below 60. Bam. Now, to our final problem.
Speed it up.
Our final problem deals with compounded continuously, or otherwise known as PERT. So this problem would start in a very different way, because PERT equation is this. PERT. So I say PERT because P-E-R-T. The problem says you owe the bank $2,000 and the interest rate is 5% compounded continuously for 2 years. How much will you owe the bank in 2 years? This problem is very easy to set up, which is P, principal amount or start amount, is 2,000. To the natural log base of E, because it's compounded continuously every second of every day, to the power of the rate, which is 0.05%, and then time, which is 2 years. Now basically this one you can just plug into your handy dandy graphing calculator, which is 2000. And then our E button is right here. Press second, and then E, which is division, to the power of, let's put some parentheses because it's a decimal, 0.05, right, multiplied by 2. And it says that here, after 2 years compounded continuously, you owe the bank $2,210 and about 34 cents. Now, with this, those are our problems, showing 3 very good uses for it. One is loans. Like if you had a student loan or something, you know, bam.
Look at that head.
And then our second problem had to deal with stocking, you know, going down. It doesn't have to be with math per se. It could be with science, you know, diseases, viruses, showing the decrease as we, let's say, get vaccinated. My first problem is really simple, you know, just putting money into a bank over time, like savings account. That's about it. Now with
that, we conclude our lesson for today, kids. Have fun.